Hello and welcome to this week's video in our course Competition Policy and Strategy. This week we are going to talk about the solutions to assignment number 8 on the topic of collusion. In the first exercise 8.1, collusion in a one-shot version reads as follows. We're asked to consider a Cournot oligopoly and in this market there is by assumption n firms who offer a homogeneous good. We know that there is a given demand function that reads Q of P equals 110 minus P. We furthermore assume that all firms have the same symmetric constant marginal costs of lower C equal 10. Now we are asked to assume that all firms simultaneously decide whether to engage in collusion that maximizes the firm's joint profits or to behave competitively. Alright, so the latter then means that they respond optimally, so according to their best responses, or to summarize, in the usual way that we would expect Cournot oligopoly firms to behave. Right? In contrast to the collusive behavior in which they, as I said, will behave as if they were to maximize their joint profits. All right, good. Let's start by task A. In this task A, as a starting point, we are now asked to show that the profits of each firm in the case of collusion, so in other words, in the case of joint profit maximization, is pi ik, so index I for the individual firm, index k indicating that we're talking about collusion profits, pi with an index I, k equals 2500 divided by n. So how can we show this? How can we show that the profits of each individual firm is exactly equal to the given expression? Well, we already hinted on how we calculate the profits of the firms under collusion, right? We already said collusive behavior means that by assumption firms maximize their joint profits. And what that then means is, of course, all firms together behave as if there were one single monopolist. Or in other words, under collusion, we achieve profit maximizing, the profit maximizing price quantity combination. And that, of course, is the result of a monopolist in the market, the profit maximizing price quantity combination. So firms act like a monopolist. Of course, calculating the profit maximizing price quantity combination in a monopolistic market at this point in this course is probably quite trivial to all of you. So I don't think we will need to go through the details, but the point is we have a profit function that results from the given demand function in this exercise as well as the given cost function in this exercise. And based on this profit function, we can then calculate the profit maximizing quantity in this market. All right, and what we can find out through this is that the profit maximizing quantity and price combination in this market that we have characterized is a quantity of 50 and then the price of 60. All right, and with this, of course, knowing the price and the quantity in the market, we can then calculate the overall profits in the market, simply multiplying the profit margin, so P minus C, with the quantity produced in the market, right? And if we do so, we then have the profits in the market as a whole. However, we were asked to provide the profits of the individual firm I, right? And each firm I has exactly a share of 1 over n in these overall profits in the market, right? So from these profits of the monopolist, we get to the individual firm's profits by simply dividing these overall profits by n. And thus we know that in this collusive situation where all firms are acting in a combined fashion, in a joint fashion, and are maximizing the joint profits. In this situation, we have individual firms' profits in the amount of 2,500 divided by n, the number of firms in the market. All right, in the next step, we are asked to show that the firm's profit in the case of deviation from this collusion is pi with an index I, d, d for deviation. And yeah, the formula for the result is already given just as it was in the previous task. So we are asked to show that the profits of the individual firm, if it deviates from the collusive behavior, reads 25 multiplied with 2 plus n plus 1, excuse me, 25 multiplied with n plus 1, all divided by n, all squared. All right, how can we do this? How can we show what the profits of the individual firm are if they deviate? Well, first, of course, we need to understand what happens in the market if a single firm deviates. All right, and what we are going to assume moving forward from here is that all non-deviating firms continue to produce the quantity they agreed upon. And of course, the quantity they agreed upon is the monopolist's quantity. All right, so all non-deviating firms continue to produce this or their share in the monopolist's quantity. So the total quantity of all other firms is not a strategic choice in this situation, in this moment where there is deviation happening, but rather it is fixed for any given number of firms n, because all other non-deviating firms are, by assumption, sticking to the collusion. All right? So with this, we know that the quantity that all other firms produce is, well, 50 divided by n, so the individual firm's quantity under collusion, multiplied with the number of firms minus 1, because there is one deviator, right? So we now know that the quantity of all other firms, so Q with an index of minus I, reads 50 times and then in brackets n minus 1 all divided by n. Okay. So that's the quantity of all other firms. Of course, if we want to find the market equilibrium, we also need to find out what the profit maximizing quantity of the deviator is, right? And per assumption, the deviator chooses a profit maximizing quantity instead. So for this given behavior of all other firms of capital Q minus I, given this behavior, the deviating firm now chooses according to their profit maximization. All right, so the deviator acts according to their best answer function, which of course is the result of maximizing profits for any given Qi for any given Q minus I. All right, so if we simply state the profit function, which is the usual one that we know from any Kuno competition, let me just repeat it, write it down over here. So the individual firm's profit, of course, is U minus I P minus C, right? So we have this general version where we have A from coming from the demand function, and then the individual firm's profits is price substituted for the demand function P, price minus marginal costs, all multiplied with the quantity of the individual firm. Now for this given exercise, of course, we know A, it was given in the exercise, it was 110. We know marginal cost C, it's 10. We know capital Q minus I, we already identified and discussed it over here. So the profit function really is only depending on one unknown, and that is the strategic variable of the firm we are now interested in, right? So we can, in the way that we are already used to from solving the Kuno competition model in general, we can start from this individual firms' profit function and find the profit maximizing best response or choice of Q in this case. And if we do so, then we can find out that in this particular case, the deviator's quantity equals 100 minus Q minus I divided by 2. Now, if we substitute Q minus I for its appropriate statement, then we can find out that the deviator's quantity, so Q with an index D, equals 25 times n plus 1 all divided by n. Okay, so yeah, we have now shown what the quantity is for the deviating firm and for all other firms. Now, if we want to find out the profits, of course, we need to find out what the price in the market is. We know the quantity for all firms. Using this, we can simply calculate the total quantity in the market, which of course is the sum of the quantities of the deviating and all the non-deviating firms. So, as calculated down here, Q, the total quantity, equals 25 multiplied with, in brackets, 3n minus 1, all divided by n. And for this total quantity in the market, we can then find out what the price in the market will be in equilibrium based on the demand function that was given in this exercise. And thus we can find out that the price in the market in this situation when one firm deviates equals 10 plus, and then as a fraction, 25 multiplied with n plus 1, all divided by n. Knowing the total quantity and price in the market, we can now calculate the profits of the firms. And in this particular case, we're only interested in the profits of the deviating firms. So, in the usual fashion that we already know, we can calculate price minus marginal costs, all in brackets, multiplied with the individual deviating firm's quantity, and through this calculate the profits. And if we do this, so simple plug in P, lower C and QD, we can calculate the profits, and indeed we find out that the profits of the deviating firm take exactly the form that we introduced in the beginning of the exercise. Alright, now to task C. In task C, we are asked to show that the profit of a firm follows the function pi if when another firm deviates from the collusion. Right. So in the scenario of collusion, so one single firm deviates now from the agreed upon strategy, from the collusive behavior. And in the previous task, we calculated the profits of the firm that deviates. In contrast to this, we are now interested in the profits of the individual firm that is not deviating, but instead which is sticking with the agreed quantity, which is sticking to the collusive strategy. All right? And this profit we now call or denote with a index I, capital F. So we have pi, index I, f, and we want to find out that this individual non-deviating firm's profits reads as a fraction 1250 multiplied with n plus 1, all divided by n squared. Alright, so from the previous exercise, we already know the price in this situation where there's one deviator in the market, right? We calculated that in task B. We also know, even from task A, that what the quantity is of the individual firm that does not deviate, right? It is the total quantity divided by the number of firms. That's what the firms agreed upon in the beginning, when they agreed on the collusive behavior. So it's quite straightforward to calculate these individual firms' profits of the non-deviators. Namely, we take the price we have found out in the previous exercise, we consider the quantity of the non-deviating firms, again, as we discussed earlier. And with this, so there it is, it's 50 divided by n, the individual firm's quantity under collusion. And with this, we can then calculate the profits of this firm, right? We have P, we have C, we have Q. We can calculate the profits of this firm. And indeed, if we do so, if we plug in the numbers, calculate it, then we can find out that it takes the exact expression that we introduced in the beginning. All right, now under task D, we're asked to consider a situation where n takes a value of 2. Or in other words, we are asked to consider a Cournot duopoly in which the firms can behave either competitively or according to collusion, which we will call cooperate. And of course, competitive behavior in this Cournot competition implies acting corresponding to the best response function, acting profit maximizing, individually profit maximizing. Whereas this collusion, this cooperative behavior implies joint profit maximization, so maximizing the joint profits of all firms and behaving accordingly on the individual level. Now we're asked to state the company's payoff metrics and determine the Nash equilibrium in this. So we have two firms, right, duopoly, and each firm has two strategies, collude or not collude, or rather cooperate or deviate, whatever you want to call it, right? Stick to the agreement or behave individually profit maximizing or according to the individual best response function in this case. So we can, of course, draw this scenario, this setting, in the usual way which we used in previous exercises, in previous assignments, when we were analyzing simultaneous games. Right? We can have this payoff matrix, which we already discussed plentiful in previous assignments. 2 players, 2 strategies. Yeah. Now there's one final hint, and that is we are given the formula which we can use in order to calculate the profits if both firms actually compete and play the conventional Cournot competition game. All right, because all other profit functions, of course, we already know from the previous tasks in this exercise. We know the profit functions that apply in the case all firms cooperate or behave according to the collusion. It was the joint profit maximization, which was equivalent to the monopolist problem under task A. We already know what happens if one firm deviates, right? And now finally we also know what happens if both firms choose to compete rather than to cooperate. And now if we use all of these profit functions that we have stated earlier in this exercise, we can calculate the profits that arise under any of these combinations. And that would look somewhat like this, right? We have 2 firms, firm 1 denoted rows, firm 2 written over the columns. And for any of these combinations, now we have the, for any of these 4 fields, we now have the combinations of cooperative behavior or collusion, and the second one, competing, acting according to the individual best response function. All right, and then in each of these 4 fields, of course, we have the payoffs, or in this case, payoffs in the sense of the profits of the firm for each of these strategy combinations. All right, we have analyzed these games several times already, but just to give you one example of how to what's actually written in this on this slide. If player 1 or firm 1 chooses to compete, and firm 2 chooses to stick with the cooperation, we're exactly in the setting where we have this deviating firm, right? So in this case, firm 1 is deviating and firm 2 is the one that is sticking with the collusive behavior. All right, so we have precisely what we called pi with an index I, comma d in a previous exercise for firm 1, and for firm 2 we have pi with an index I, comma f, right? Now we're finally asked to calculate or to find the Nash equilibrium in this scenario, and of course we can do this by simply underlining the best responses. And if we do this, well, let's compare payoffs of firm 2 for any given strategy of firm 1. We can see that if firm 1 chooses to cooperate, it is profit maximizing to compete. If firm 1 chooses the strategy compete, it is again profit maximizing to choose compete for firm 2 as well. And now if we flip this game around and consider the profit maximizing best responses for firm 1 for any given strategy of firm 2, we will find out that it's exactly the same. It's always profit maximizing for firm 1 to choose the strategy compete. And with that we have found the Nash equilibrium in which both firms are competing, which of course means that the conventional Cournot competition market equilibrium is indeed the Nash equilibrium in this situation. Which of course implies that in this static version of this game, where there is a one-shot, where it is a one-shot game, so there's one single period we are looking at, it can never be that a collusion or that this kind of cooperation between firms is stabilized, because we see what is essentially a prisoner's dilemma, right? Both firms could have higher profits if they were able to commit to cooperation, but because this is a one-shot game and firms are making their decisions simultaneously, we are in the situation of the prisoner's dilemma, where both firms have an incentive to individually deviate from this Pareto optimal situation, so that in the end we'll find ourselves in a situation where it is the only Nash equilibrium to compete for both firms.